All right. We're going to do section 4.1. What this section is going to be over is different types of functions and graphs, and whether being able to tell whether a graph is a function. It's a big part of several exams, just being able to look at a graph and tell whether it's a function or not. So I guess what we need to start off with is the definition of function. So the definition of function is saying that each x can only have one y value. Okay, so it's a line, it's a set of points, it's a set of solutions, but each x, okay, so each independent variable can only have one dependent variable. Okay, so each x can only have one y. That's important to know. Okay, and so what that kind of means is let's say I have a function of, let's say x squared is equal to 7. Okay, so this is a function. And if I plug in points, let's say x equals 1, can I get a solution from that? Okay, so do I have a definite solution for the answer, or for the point x equals 1? And let's not say 7, let's say y. So x squared is equal to y. So when I plug in 1 squared is 1. So I get a definite answer. Okay, so if I plugged in, let's say 3, would I get a solution? Well, 3 squared is 9. Okay, so what about -3? Well, -3 is also 9, but I still get a solution. Even though it's the same solution, it's a solution. Okay, so can I get a solution from it? That's what you're looking for. But what happens if it was y squared is equal to x? Okay. Well, let's say if x is equal to 9. Okay, can I be able to tell what y is? Does y have to be a number? Well, let's look. If x is 9, so now I have y squared is equal to 9. What would my answer be? Well, 3, right? 3 squared is equal to 9. But also, y could be -3, because -3 squared is also 9. So see how when I plug in 1x, I can get 2 y's. Okay, so this is not a function. So this is the definition, or the example of not a function. Okay, where this is a function. Okay, so think about that. Each x can only have one y. So when I graph, again, this is my x, this is my y. So let's say I picked a point. So x, let's say x is 1. Well, what's my y value? So then when you pick that, you just go to the graph. Well, it's up here, but it's also down here. Okay, so see how I would have two solutions at once. So this is not a function. Okay, and you're going to be able to tell that based on graphs by the vertical line test. Okay, and if it hits twice, not a function. And what do I mean by that? So let's say I drew a vertical line. See how this vertical line would hit the graph here and here. Same thing here. I drew a graph, it hit twice. Okay, so if there's any point where it hits twice, the answer is no. This one. Only hit once, hit once, hit once. See, there's no point where I can hit it more than once. So this one is a function. This is a yes. Okay, so this is a function. Okay. This one, okay, same thing. Now I drew this kind of funky here, but technically it would only hit once everywhere. This is the graph kind of like x cubed. So this is a function. And this one, okay, even points. See how I draw the line right here and it hit it twice? So this is not a function. Okay. So that's how to tell based on graphs whether it's a function or not. Okay. Now the next thing, it says give the domain and range of each of the graphs on the left. Okay, so we have to give domain and range of these graphs. So I'll tell you what, I'm just going to redraw the graphs. And then the last one is the dots. That would be 4, 0, 3, 4, 3, 1, 0, 4. All right, I'm sorry, 4, 0. This one's wrong, 0, 4. Okay. All right, so domain and range. What domain values mean is the x values. So what x values are a part of the graph? What range is the y values. Of the graph, okay? So now if I looked at the first one, and again, x goes left and right, y goes up and down. And when you read a book, okay, we always read it left to right. Okay, so we're going to go from negative infinity to infinity each time. Same thing here, up and down, we're going to go negative infinity to infinity. So that one's kind of opposite. So we need to see at what point do the x's actually start. So if I start clear over here, there's no graph here. Okay, so as I move, I need to find the first point, okay, that is part of the graph, okay, and that's the x value right there. Okay, and if I look, and if I count, 1, 2, 3, 4, 5, 6, okay, so on your graph, it's going to be -6, okay, and then I need to see where it stops, so I keep going over here until it stops, and see how there's nothing over here, so it had to stop at some point. Well, this is the farthest right point, okay, so I need to find what that x value is. All right, so if I count 1, 2, 3, 4, okay, so my domain on this would be -6 to 4. My range, I start down here at the bottom. See how there's nothing right here. Okay, so where does it start? Well, right there. And I need to see what y value that is. And that would be -2. Okay, if I keep going up, okay, it's nothing up here, so it had to stop somewhere. So it stopped right here, so I count up, and that would be 8. -2 to 8. So this would be the domain, and this is the range. Okay, it's the domain of this. Now this one. Oh. Domain. Again, x values. Now see how there's arrows on the end. The arrows will keep going forever. Okay, so that means it'll go left forever and it'll go right forever. Okay, so this one's going to be -infinity to infinity. Okay, so it goes all the way over here at -infinity, all the way over here at infinity. Okay, now let me go back real quick. Okay, see how it was 4 and it was -6. Okay, technically I shouldn't have parentheses here. Okay, I should have brackets. So on domain and range, you're going to start dealing with brackets again. Okay, so it was 4 was a part of it, 8 was a part of it, so we need brackets here and brackets here. Okay, so if it is equal, you use brackets. Now, you can't tell where -infinity and infinity actually are, so that's why it's going to be parentheses anytime you use infinity. Okay, now range. Range, I start at the bottom, work my way up. Okay, so it hits it somewhere right here. There's the lowest y value. Okay, and if you look, it's 1, -9. Okay, so -9 is the farthest y value. So bracket -9, and then it's going to go all the way up forever. So that's why it's infinity. Now, anytime you use infinity, you should use a parenthesis. This one. Okay, domain, there's arrows on the end, and it'll always go down forever, always go up forever, it'll always go left forever, always go right forever. Okay, so it's going to be -infinity to infinity, and then range will be the same thing. Again, this one, domain, the x values. Okay, so it's going to be a set of points since it's not a graph. It's all the x values. So it's 0, 3, 3, 4. Now you don't have to put it twice. And the range, all the y values, 4, 4, 1, 0. So put them in numerical order. And that's your domain and range for each of those. Okay. All right. The next one says rewrite as a function of x. Okay, so I'm given the equation x minus 6y over 2 is equal to -2. When you rewrite as a function of x, that means solve for y. Okay, so we just get y by itself. So y is right there. So don't mess with that. Get everything else to the other side. So the first thing I need to do is multiply by 2. So now I'm left with x minus 6y is equal to -4. I'm going to subtract off my x since it's positive. So -6y is equal to -4 minus x. And then I divide everything by the -6. So y is equal to -4 divided by -6 minus x divided by -6. And so y is equal to 2/3. Minus a minus makes a plus. 1/6 x. That's solving for y. Okay. Now the next one says evaluate at x equals 2. So just plug it in. Plug it in for x. So y is equal to 2/3 plus 1/6 times 2. Again, when you multiply this, you only multiply by the top. So y is equal to 2/3 plus 2/6, which is 1/3. 2/3 plus 1/3 is equal to 1. So your answer is 1. Now it says find the domain. Okay, so they're going to ask you this a lot to find the domain. Okay, and without graphing it, okay, the way to think about it is this. Okay, what restricts a function? What makes a function not have numbers? Okay, especially x. What makes you not be able to put x in? Well, there's 2 restrictions for a domain. Two main ones. Is it a fraction? Okay, and the fraction would mean like 3 over x. You can't have 0 in the bottom. So x could not be 0 here, right? Or square roots. Or any type of radical. Okay, so if I had like the square root of x, well, you can't square root negatives. So x could not be, x must be greater than or equal to 0 here. Okay, that would be that. Okay, so those are the restrictions. So what you need to look for is, does it have a fraction or does it have a square root? Those are your 2 questions. If the answer is no, there's no restrictions at all. Okay, so this one, is there any fractions where x is on the bottom? Now the answer is no. Okay, is there any square roots? Also no. Okay, so my domain is going to be -infinity to infinity every time. Okay. All right. Same sort of thing. Cross off the range. You don't have to find the range on these. Okay, we're not going to graph them yet. Okay, so the first one is 3 over x minus 2. Well, what can x not be? Okay, there is a fraction. So x cannot be, you can't have 0 on the bottom. So x cannot be 2. All right. So if I drew a number line of everything I could have, it would start with -infinity, start with infinity, or end with infinity, and you cannot have 2. But you can have everything else. So how you would write that is you would go -infinity to 2, but put a parenthesis because that means you can't have 2, and then 2 to infinity. So if you look at this, it means everything except for 2. That'd be your first one. The second one, for x plus 5. Is there fractions? No. Is there square roots? No. Okay, so it's negative infinity to infinity. The next one. Okay. This one's a little bit different. Fractions, no. Square roots, no. But you got squares in here, okay, which really restricted a ton except for this, the y plus 2 squared. So if you look at this, anytime you have x squared and y squared, you should start thinking it's a circle. Okay, with a center point of 3, negative 2. There's my center. And then my radius is, remember, r squared is equal to 25. So r is equal to 5. So I go up 5. 1, 2, 3, 4, 5. Right 5, 4, 5. Down 5, 1, 2, 3, 4, 5. Left 5, 1, 2, 3, 4, 5. And you draw the circle. Okay. Now domain again is x values. Okay, so it starts right there, and that's at negative 2. Now it is negative 2, so I shouldn't put a parenthesis there. I should put a bracket. And then it ends at 4, 5, 6, 7, 8. Now it is 8 too, so this should be a bracket. So that's my domain. I could do the range on that one pretty easy. It's from here to here. Okay. Last one. X plus 5. Well, again, you cannot have negative in here. It can be 0. The square root of 0 is 0, but you cannot have negative. So x cannot be less than, so it has to be greater than or equal to what makes this 0, and that's negative 5. So it has to be greater than or equal to negative 5. So if I graph that, here's negative 5. It has to be greater than, so that means it has to be on this side somewhere. It could be equal to, so that's going to be a bracket. Okay, realize that this is infinity clear out here. So my interval is going to be negative 5 to infinity. That's my domain. All right. The last ones, or the last thing we got to do is just plug in functions. So if I'm given f of x is equal to 3x plus 5, I got to be able to plug in answers. Okay, so if they ask f of 2, well, we replaced x with 2, so you got to do the same thing. So we just replaced that with 2. That's the same thing as 3 times 2 plus 5. 3 times 2 is 6. I don't know why I put that there. Plus 5 is 11. So my answer is 11. The next one, f of x plus 2. Again, you replace x with whatever in here. So it's 3, x plus 2, plus 5. Just FOIL or distribute. Simplify. 3x plus 11. The last one, f of x squared. Replace the x with whatever in here. So 3 x squared plus 5. 3x squared plus 5. The last one. Square root, radical x plus 5. Plug, again, whatever is in here in. So that would be radical 2 plus 5. Okay, and you cannot simplify that. That's your answer. The next one, x plus 2. Plug it in. Radical. X plus 2 plus 5. That's your answer. And the last one is x squared. Radical. X squared plus 5. Okay. Now, can you simplify this one? Okay. The answer is yes. Okay, but think about this. If I plugged in, let's say 2. 2 squared is 4. Square root of 4 is 2. 2 plus 5 is 7. Okay. So that would be the same thing as saying x plus 5, right? So x plus 5. So let's put in some examples. Let's say x equals 2. And that would be the square root of 4 plus 5, which is equal to 2 plus 5, which is equal to 7. Okay? There's your 2, there's your 2. Now, my question is, what happens if x is equal to negative 2? Well, negative 2 squared is still 4. 4 plus 5, which is equal to 2 plus 5, which is equal to 7. Notice that this is not the same as this. Okay? At any point, will this ever be negative? The answer is no, because you're going to square it, and then square rooting it makes it positive again. So, what will always make something positive? Well, that's the absolute value. Okay, so when you simplify this, the answer is going to be not just x, it's going to be the absolute value of x plus 5. Okay, let me know if you have any questions. That would be section 4.1.